Hi everyone, you're welcome to Explore Insights. And in this context, we want to look at digital electronics. What is digital electronics? Digital electronics is a field of electronic science that deals with the design, implementation, and application of digital circuits. Now, these digital circuits use binary signals, which are represented by two different voltage levels, to perform various computations and operations. In this course, I'll be covering 8 topics of digital electronics. 1, we have the number system and binary arithmetic. 2, logical gates and Boolean algebra. 3, combinational circuits. 4, sequential circuits. 5, logical families. 6, semiconductor memories. 7, the analog to digital converter and the digital to analog converter, also referred to as AD and DA converters. And lastly, the microprocessor. So let me further take you through on the subsection of each of these topics. Now, when we talk about the number system and binary arithmetic, I want you to consider it as the fundamental concept in digital electronics and computer system. So the binary system is the most commonly used number system in digital electronics, as digital signals can only have 2 values, 0 and 1. Now, for the number system, we'll be looking at decimal number system, binary number system, the octal number system, hexadecimal number system. Now, the conversion between the different number systems. Furthermore, the representation of negative numbers in binary. And lastly, 2 complement representation. Now, talking about the binary arithmetic, we'll further look at the addition and subtraction of binary numbers, overflow and carry in binary arithmetic, multiplication and division of binary numbers, the arithmetic logic unit and its implementation in digital circuits. We'll also consider the binary shift operation and the bitwise operation. Now, kindly note that the ability to perform arithmetic operation and represent number accurately is crucial in digital electronics and computer systems. Now, understanding basic arithmetic and number representation is also important in the design of digital circuits, algorithm, and communication system. So let's go to the next one. Number 2, we have the logic gates and the Boolean algebra. Now, when we talk about the logic gates and the Boolean algebra, they are also fundamental concepts in digital electronics. For the logic gates, we'll be looking at the building blocks of digital circuits and perform basic logical operations such as AND gates, OR gates, NOT gates, NAND gates, NOR gates, XOR gates, XNOR gates, and lastly, the implementation of logic gates using transistors or other digital circuits. Moving over to Boolean algebra is a mathematical system for analyzing and manipulating logical expression. So in this case, we'll consider the basic concept of the Boolean algebra, Boolean function, and truth tables. We'll also check out the Morgan laws, simplification of Boolean expression, the K-maps, and also the canonical forms, which could be in the SOP or POS. These topics provide the foundation for digital logic design and the implementation of digital system. Ability to analyze and manipulate logical expression is essential in the design of digital circuits, even from simple gates to complex circuits and state machine. So understanding this concept is essential in the design of digital logic circuits, as well as analyzing and optimization of their performance. Let's go to the third one, which is the combinational circuits. Combinational circuits are a type of digital circuit that outputs a function of the current input. The output of a combinational circuit depends only on the current input and not on previous input or the state of the circuit. In this case, we will consider the design of combinational circuits, which include the use of the Boolean algebra and logic gates to design combinational circuits, the minimization of Boolean functions to reduce the number of gates in a circuit, the implementation of decoder, encoder, multiplexer, and demultiplexers. Now, we'll also look at the design of arithmetic circuits such as adders and subtractors. And lastly, we'll look at the design of logic functions such as parity generators and checkers. Next, we'll look at analysis of combinational circuits. Here we'll consider the hazards and the race condition in combinational circuits, the timing analysis and the delay calculation. The third, we'll look at the circuit testing and the fault detection. And lastly, we will look at the power analysis and optimization. Remember that combinational circuits are widely used in digital systems, from simple input-output function to complex data processing. So understanding the design and analysis of combinational circuits is important in the implementation of digital systems and in ensuring their correct and efficient operation. Let's move to the fourth one, which is the sequential circuit. Now, talking about the sequential circuit, it's a type of digital circuit that has memory and whose output depends not only on the current input, but also on the previous state of the circuit. Considering the design of sequential circuit, we'll look at the use of flip-flops and latches to design sequential circuits. We'll also consider the types of flip-flops such as XL, JK, and D. We'll also look at the implementation of counters, shift register, and finite state machine. And lastly, we'll look at the design of synchronous and asynchronous sequential circuits. Next, we'll consider the analysis of sequential circuits. Here we'll see the timing analysis and delay calculation in sequential circuits, the circuit testing and fault detection, analysis and optimization, hazard and race conditions in sequential circuits, and also we will do the verification and validation of sequential circuits using simulation and formal methods. Remember that sequential circuits are widely used from simple memory elements to complex controller and state machine in digital system. So understanding the design and analysis of sequential circuits is important in the implementation of digital systems and in ensuring their correct and efficient operation. So let's look at what we have next, which is the logical families. These logical families are sets of electronic logical gates and digital circuits that are based on specific technology and circuit design. Different logical families have different properties and specifications, such as power consumption, speed, noise margin, and voltage levels, which determine their suitability for different applications. So we will look at the types of the logical families, which include the TTL, the CMOS, the ECL, the RTL, and the DTL. Understanding the different types of logical families and their properties is important in the design of digital systems and in choosing the appropriate technology for different applications. So let's go to the sixth. We will look at the semiconductor memories, which are the electronic memories device that use solid-state semiconductor technology for data storage. They are widely used in digital systems for storing information and programs. So in this case, we will consider the type of semiconductor memories, which include RAM, ROM, PROM, EPROM, EEPROM, and flash memory. Now let's move over to what we have on our seventh topic, which is analog to digital converters and digital to analog converters. Now, these are the two important components in digital electronics. Looking at the AD converter, we'll consider the sampling rate and the quantization error, the different type of the AD converters. We'll also look at the error correction techniques, the dynamic range, and signal to noise ratio, considered as the SNR. And also, we'll look at the application of AD converters. And next, on the DA converters, we'll likewise be looking at the sampling rates and the quantization error. We'll also check out the types of DA converters. We'll consider the digital to analog conversion techniques, the output impedance, and the load requirements. And we'll also look at the linearity and accuracy. And lastly, the application of DA converters. And last but not the least, we want to look at the eighth topic, which is the microprocessor. Now, a microprocessor is a compact and integrated device that contains the processing units of a computer. It is responsible for executing instruction and performing arithmetic and logical operations. So in this case, we will be looking at the architecture, the instruction set architecture considered as ISA, the clock speed and the processing power, memory management, the interruption and exception, and lastly, the power consumption. So I warmly welcome you to this course. Be rest assured that it's going to be an enjoyable and understanding lecture for you. Do well to follow me in my subsequent video as I take you through this course. So have a nice time. Bye.